Solve the inequalities below for the given variables. Represent your solution on a number line. So A, I am going to go ahead and turn this into an equation first to find my boundary point, right? So it's 3 times the quantity of 2k minus 1 is equal to 9. I know that my boundary is going to be an open circle because this is strictly less than. And if I divide both sides by 3, I get 2k minus 1 is 3. Add 1 to both sides, I get 2k is 4. Divide by 2, k happens to be 2. So my boundary is at 2. So on a number line, I could show here's 0, 1, 2. And I'm going to test the number 0. When I put 0 into the original inequality here, it gives me, well, let's mark my boundary point. So my boundary point is at 2, and it's an open circle, not filled in. And when I put 0 in, right, because I want to check this point and see if this makes it true or false, this gives me 3 times, this would become -1 inside the parentheses. So this is just -3 is less than 9. That is true. So everything to the left of my boundary point is a solution. So these are all solutions. Everything that direction. All right, let's look at B. So again, find the boundary point first. So I've got 2p over 5 equals 6. This boundary is going to be a solid dot because this is less than or equal to. Therefore 2p, oops, I've got shapes turned on. Therefore 2 times p is equal to 30, and p is the number 15. Right, let's see, 5, I multiplied both sides times 5. I got 2p is 30, divide both sides by 2, I get p is 15. So on this one, if I graph it as a number line, my boundary here's 0. I'm going to say way over here is the number 15. And if I test 0 into that original inequality, if I put 0 in there, that becomes 0, and 0 is less than or equal to 6. So that means everything, including the 15, right, because this one included the boundary point, everything including this is a solution. So all of these points are solutions. And I didn't write down the what it is. This is p is less than or equal to 15. Yes, that's correct. Did I write the answer for A? No, I didn't. A, I should say, that was K. I should say K is strictly less than 2. It can't be equal to 2. All right, 2 more. I think I'll do C right here. C is going to become the equation -2 plus 8n is equal to 2. The original inequality was less than, but I'm finding the boundary location. So I'm going to solve this for n to find the location of the boundary. Adding 2 to both sides, I get 8. N is 4. Divide both sides by 8, I get n is 4/8. N is 1/2. So my boundary point is at 1/2. Here's 0. Here's the number 1. And that means right in here would be 0.5. This is 1/2. So I can still test 0, right? So I'm going to plug 0 into that. If I plug 0 in, then it's going to become -2 is greater than 2. That's false. That's false. This point did not work. That means instead of going where the 0 is, I have to go the opposite direction this time. So, and the boundary was an open circle. So we have an open circle at 1/2. And then it is everything to the right of that boundary point. So all of these points are solutions. Okay, last problem. I've I've kind of boxed this in. It's hard to see it at this point. I can see D. So, oops, I'm not going to use that pen to do it. So on D, we've got 7t minus 4, and that's greater than 2t minus 4. They're both minus 4. That's interesting. If I add 4 to both sides, it says 7 times something is greater than 2 times something. Okay, that's crazy because you know what? That is always going to be, isn't that always going to be true? How in the world could that ever not be true? Wait, what if t is negative? Oh, yeah, I see. Okay, so I'm getting ahead of myself. I should treat this like an equation, right? And if I find the boundary location, I'm going to subtract 2t from both sides. So I get 5t is 0. And if I divide both sides by 5, I get t is 0. So my boundary is at 0. That means I can't use 0 as my test point. So here's 0. And this boundary is, based on the original problem, this is going to be an open boundary. And I'm going to test positive 1. When I put positive 1 into this inequality, this becomes 7 minus 4, which is 3, is greater than 2 minus 4, which is negative 2. That is true. That's true. If I put 10 into that, that's going to become 70 minus 4, which is 66. And 20 minus 4, yes, 20 minus 4 is 16. So it's going to be the things that are above the boundary location of 0. So all of these values are greater than, or would be solutions rather. So the answer here is t are all those things that are strictly greater than 0 but not equal to it. So again, the technique here is we consider these to be equations. We solve the equations to find the location of the boundary. If the symbol is less than or greater than, then my boundary is open. If the symbol is less than or equal to, or that's greater than or equal to, or less than or equal to, then the boundary is filled in. Okay, and then and then I test above or below the boundary to see which side gets shaded. So that's our general technique there for solving these one variable inequalities.